here is the spatial differentiation model, or what we might call the hotelling model. So we have two firms. We have firm A and firm B, and they are located along a linear line. And the question we want to know is which consumers are going to consume from firm A and which ones are going to consume from firm B, and what prices would they charge to try to attract the most consumers. So if we think of this area right here in the middle, these are the individuals that have a choice, in a sense, to go to firm A or firm B to buy the good. And so we want to identify point E, which is the indifferent point, that individuals would be indifferent from going to A or B to buy the good. So let's look at that. So let's first think of what are the costs of buying from firm A? Well, it's the price they pay plus the cost to travel times the distance they would go. And this should equal to the price of firm B plus the cost of travel times the distance. And so that is the indifference point. And from here we can solve for x. So I can get x is equal to price of B minus price of A over C plus y. And it's also helpful to note now, well, if we think what y is, well, if this whole distance here is defined as L, then L is equal to A plus X plus Y plus B. Therefore, y can be rewritten as L minus A minus X minus B. And so we can substitute that in. So X is equal to this price of B minus price of A over C plus L minus A minus X minus B. And now we have an X over here on that side, right here. So let's go ahead and bring it to the other side. So we get X is equal to PB minus PA over 2C plus L minus A minus B over 2. Right, so that is the quantity of X. So how many people purchase from X? Well, the profit function will then be the price that they charge times this quantity, PB minus PA over 2C minus or plus L minus A minus B over 2 plus the area A, which is now these individuals right here are going to go to A. So if this is our profit function, we can now take the partial derivative with respect to the price of good A, and this is going to give us PB over 2C minus PA over C plus L plus A minus B all over 2. And we set that equal to 0. So now we solve for PA. So PA is equal to PB over 2 plus C times L plus A minus B all over 2. So this here we can define as a reaction function. So given the price of good B, A can choose their best response through this equation. Now, through symmetry, the reaction function for price of B is PA over 2 plus C times L plus A minus B over 2. And so this is also the reaction function for firm B. So now that we have that, we can then substitute PA into here. Let's do that into red, and then solve out the equation. And what you get for the optimal price for good A is equal to C times L plus A minus B over 3. And the optimal price that B charges is C L plus B minus A, slight difference, over 3. And so these are the optimal prices that they would charge to maximize profits, to be able to extract most of the profits from these individuals. And we do so by defining what this indifference point is between E, such that these consumers here in X go to A, and these consumers here in Y go to B. And so this is an example of the hoteling model.